Welcome back. In the last couple of videos, we kind of pointed out how slope quickly goes from being y2 minus y1 over x2 minus x1 to some kind of a more relative term, which is f of x plus h minus f of x. That's y2 minus y1 over x2, which is x plus h minus x1, which is the original x. And of course, immediately you should understand that these cancel out and you just end up with h here. So I'm just going to write it that way off the get-go. And I'll stop highlighting it there. And for us, if I choose a point, I'm going to pick a point here. I'm going to pick a point here. If I draw a line between them, say something like this, then it means that this distance here is our h. And if this is my x and f of x, as in the y value, then up here will be a coordinate of x plus h and f of x plus h on our parabola there. Second parenthesis, forgot about it. Okay, so we have this definition. Why does it matter? Why does it actually matter? Let's take the yellow away and let me play around on the parabola here. Well, on a curve like this, slope isn't just one value. I mean, we read from left to right, so the slope of this right here is this direction. And the slope right here is this direction. So if this is like a minus 8, this is more like a minus 2. So you see the problem? We can't calculate a number. It's not a number. It's going to be a formula that tells us where to find slopes. This one here would be like a plus 5. So this ranges, this parabola has, every slope is in this parabola somewhere. So if I want to approximate the slope at, say, here, say this is the spot I want to find the slope, and you and I know it's going to be pretty positive. Maybe it's 6, maybe it's 20. But if we want to find it, that's where Newton comes along, and he says, okay, what we'll do is we'll take a point here, and we'll draw a line between them. And we'll get some value for the slope. Say this is like a minus 1. And that's not very accurate. So instead of that, maybe we'll just make that a dotted line to kind of show that we tried that and we got like a minus 1. But if I move the point along the graph here to maybe here and take a new line, this is a slope of like positive 1. And we know that the correct slope, let's say we know somehow ahead of time, is 5. Okay, so this one is still not very accurate. But I'm sure you're seeing where we're getting. As I move closer and closer, well, what if I put a point here and I draw a line? This is going to be more like positive 4. We're already getting pretty close. But if I bring that extra point real close to like right here, and I draw a line, well, I want to take some of this yellow away. If I bring that point real close and I draw a line, this is going to be like 4.8. And that's much warmer. So of course, as you might imagine, if I'm able to put 2 points on top of each other here, you're going to get that perfect 5. But in the math, that would be dividing by 0, because there's the h value is the distance between the 2 points in the x direction. And that's why we call it h, because we can't divide by 0 in math. So we'll divide by h. That's literally how this works. So can I take away all this yellow, or did I go too far ahead? Great. Let's play around with this a little bit. Okay? I'm going to do something like f of x equals x squared. Since I've already written it here, we'll play with this formula, and we'll stick this in to our definition of slope, which we're now going to call the definition of derivative. We're going to take away all the slope stuff, and I'm just going to call this derivative, which is kind of like saying the underlying way in which this graph gets made. Because the formula we come up with determines the way you would step infinitely small steps at a time to produce this thing. I'll show you what I mean here. So we have one point. It doesn't matter where. Say we have a couple of points here and we want to find the distance, the slope between them, but we're going to bring them to infinitely close together. Okay, well, we have an f of x already, so that'll get plugged right in. But if I want to do f of x plus h, that's going to be x plus h squared. Because for functions, the input here is the same as this. So wherever I see this x, I have to square it. And then we're going to do a minus x squared, because this is exactly what it says to do. And then we're going to divide by h. I'll put it horizontally like that just to give us some space here. Well, if you FOIL x plus h squared, you're going to get x squared plus 2xh plus h squared, and then we have a minus x squared here. This is all divided by h still. Well, positive x squared and negative x squared are gone. And this h can cancel out like this, and an h squared cancels out. So what we're left with is 2x plus h. And now you may remember, h is 0. It's always been 0. And now we're going to just wipe that out, and we're going to end up with 2x. And what we do is we say f prime of x, which is to say the derivative of the function of x is equal to 2x. And what does that mean? Well, when I come to my graph here, and I pick a point, let's say we're at the origin, and it's 0, 0 here, what's the slope? If you look carefully, you can tell that the slope is perfectly flat, which is 0, just by inspection. We can see it. But the formula says if I put 0 in for x, then I should get 2 times 0 equals 0 for the slope at that spot. Another example for that. If I come over here to the point 2, 4, because x squared is the formula, right? Then I can put in f prime of 2 is equal to 2 times 2 equals 4. That does not mean the y value is 4. It means that the slope right here of the line is 4. That was a little tricky part for me. I'll give you another example. It's going to really hammer in here in a minute, I'm hoping. Over here, let's pick the coordinate point -5. Well, f of x is x squared, so the y value would be 25. This is not very to scale, I have to admit. But the slope here is going to be more like this. And so f prime of x, i.e. f prime of -5, is 2x, so that would be 2 times -5, which is equal to -10. So that tells us the slope of the parabola right here is -10. This is how we find the slope anywhere on a curve. Now we'll get much more complicated, but if you absorbed it this way, you're ready to move it forward.